Hello students, welcome back to the 9th video of this playlist. In this video, we will be solving the last question from the most recent past paper of Physics Unit 4, that is the October 2024 Unit 4 paper. So let's get started with the last question of this paper. So here the question says, the diagram shows the track of a omega plus particle in a bubble chamber. The particle decays at point x. So the omega plus particle, it decays at point x. Okay, there is a magnetic field of magnetic flux density B perpendicular to the velocity of the particle. Okay, now in part A, the question says the omega plus particle is following a circular path of radius 1.99 meter. Calculate the value of B. Momentum of omega plus particle, it is given as 3.67 times 10 inverse 19 kg per second. Okay, so the question is asking to find out the magnetic flux density. Okay, so the momentum of the omega plus particle, it is given, so we can find out the magnetic flux density using this formula. BQV equals to mv squared over r. That's the equation for a particle moving in a bubble chamber, right? Okay, so v cancels out, so you will have bq equals to mv over r. So we need the value for b, right? So b would be mv, that is mv is the momentum p over r times q. Okay, so what's the momentum here? The momentum is given as 3.67 times 10 inverse 19, and the radius of curvature, it is given as 1.99 meter. And now the charge of omega plus particle, it is same as that of charge of an electron, that is 1.6 times 10 inverse 19 coulomb. Okay, so the value for B we will get here. Use your calculator to get the value for B. Okay, the value for B, it is 3.67 times 10 inverse 19 divide 1.99 times 1.6 times 10 inverse 19. So that would give you 1835. The value for B, it is 1835 over 1592, that much Tesla. So in decimal, in 3 significant figures, we can write it as 1.15 Tesla. 1.15 Tesla. That's it. That's the answer for part A of question number 18. Fine. Okay, next is part B of question number 18. So here the question says the equation shows the decay of the omega plus particle. Omega plus, it decays into pion plus particle plus neutron. Okay, so part 1 here, it says the omega plus particle is made up of 2 up quarks and 1 strange quark. State what type of particle omega plus is. Okay, omega plus, so it is made up of 2 up quarks and 1 strange quark. So in total there are 3 quarks in this omega plus particle. So we know that the particles made up of 3 quarks, these are called what? Baryons. So it is a baryon. Okay, fine. Okay, next is part B2. So in part B2, the question is asking to deduce whether the conservation of charge and the conservation of lepton number apply to this decay. Okay, we have to deduce whether charge is conserved or not and whether lepton number is conserved or not. Okay, at first consider the charge. At first consider the charge. So charge on left hand side. On the left hand side of the equation, on the left hand side, the total charge, it is +1, right? It is +1. And on the right hand side, total charge, it is +1. The pion plus particle, it has charge +1, and neutron has charge 0, neutral, equals to +1. So what? Left hand side equals to right hand side. Hence charge is conserved in the decay. So charge is conserved in the decay. Okay, next is lepton number. Lepton number. Okay, so on the left hand side, consider the lepton number. On the left hand side of the equation, lepton number is 0 because baryon omega plus, it is alone on the left hand side, so it has lepton number 0. Total lepton number is 0. And on the right hand side, what's the total lepton number? Total lepton number on the right hand side, it is pion plus neutron. So neutron is a baryon, pion is basically a meson, right? So both are hadrons, so they don't have any lepton number. So on the right hand side, the lepton number is also 0. So therefore left hand side equals to right hand side. Hence lepton number is conserved. Okay, lepton number is conserved in the decay. That's it. That's what the question has asked to show. Fine. Okay, next is part 3 of B. Okay, so in part 3, the question says the diagram shows the directions of the 3 particles involved in the decay. Okay, these are the 3 particles. Okay, it shows the direction. Determine the magnitude and the direction of the momentum of the neutron. Momentum of omega plus particle, this is 3.67 times 10 inverse 19 kg/s. Magnitude of momentum of pion plus particle, it is 1.07 times 10 inverse 19 kg/s. Okay, so we need to find out the direction of the momentum, magnitude. Okay, magnitude and direction. So consider the magnitude at first. So we know that total momentum before and after the decay, it should be equal. That is, momentum should be conserved. So here the neutron, it is moving in this way. That means it has momentum to the left side. So the momentum of the neutron on the left side, that is horizontal component of its momentum, it is equal to the horizontal component of the momentum of the pion plus particle, right? So we will consider that fact to find out the horizontal component of momentum of the neutron. Okay, so what's the horizontal component of the momentum of neutron? It is let's consider, we have to use this as sin theta. Okay, this is the resultant momentum, this is the vertical component, and this is the horizontal component. Okay, so we need this component, the horizontal one, so we have to use sin theta. Okay, so sin theta equals to the horizontal component of momentum over the hypotenuse, the total momentum. Okay, the total momentum, let's say this is P. Okay, momentum of pion plus particle is given, momentum of pion of omega plus particle is given. Okay, so horizontal component we will get, it is p sine theta. Fine. Okay, now consider the vertical component. So vertical component could be found using cos theta. So p vertical over p. So vertical component p vert equals to p cos theta. Okay, now consider the horizontal component of the momentum of pion plus, it is equal to the horizontal component of the momentum of the neutron. So we can write the horizontal component p sine theta equals the horizontal component of the momentum of pion plus. Pion plus has momentum this much, so this would be sine 65. We have to use sine 65. Okay, so 1.07, so that would be 1.07 times 10 inverse 19 sine 65 degree, that much kg/second. This is the p sine theta. Okay, and then consider the vertical component of the momentum of the neutron. So vertically, the momentum, the total momentum of the pion plus and the momentum of neutron, they will add up to become equal to the momentum of omega plus. So we can write here vertically, we can consider p cos theta plus the vertical component of the momentum of the pion plus, it is 1.07 times 10 inverse 19 cos 65 degree. Horizontal component was sine 65, so vertical component would be cos 65. Horizontal component was sine 65, so vertical component would be cos 65. Okay, so 1.07 times 10 inverse 19 cos 65 degree. This is equals the momentum of the omega plus particle before the decay. This is 3.67 times 10 inverse 19, that much kg/second. So from there we can make p cos theta the subject. So p cos theta would be equal to let's calculate it using the calculator. 1.07 times 10 inverse 19 times cos 65 degree, and then we need to subtract it from 3.67 times 10 inverse 19. So we will get, okay, so p cos theta plus the vertical component cos 65 pion plus, okay, 1.07 okay, I have done a mistake, 10 inverse 19 times cos 65 degree. Okay, so 3.67 times 10 inverse 19 minus this momentum, okay, minus the answer, that would give you 3.21779.846 times 10 inverse 19 kg/second. Now divide what? P sin theta over p cos theta. So sin theta over cos theta is tan theta. So tan theta would be equal to what was the value for sin theta? It was 1.07 times 10 inverse 19 sine 65 degree over the value for p cos theta, that is 3.21 ... times 10 inverse 19. So the value for theta, it would get, let's calculate it out. So 1.07 times 10 to the power negative 19 sine 65 over 3.21 ... times 10 inverse 19, and then 10 inverse answer, that would give you 16.777125 403 degree. Okay, we got the angle theta. Okay, now we need to find out the magnitude for momentum. So just you can put this value for theta in any of the equation to get the value for p. Okay, so p equals to, let's say we have there 3 point, I'm considering this equation, so 3.21 times 10 inverse 19 over cos theta. So cos theta is 16.7 something. Okay, so now calculate. If you do so, cos answer, it was saved in my calculator, so cos answer, and then in the numerator 3.21779846 times 10 inverse 19 over the answer cos theta. So that would give you 3.36075,002 times 10 inverse 19, that much kg meter per second. Okay, so we got the magnitude, we got the angle. Now we will just put in the final answer. Magnitude of the momentum up to 3 significant figures. This is 3.36 times 10 inverse 19 kg meter per second, and the direction of momentum, that is theta, it is 16.8 degree. 16.8 degree to 3 significant figures. 16.8 degree. That's it. So simple concept. The only concept we have used here is that conservation of momentum in 2 dimensions. That's it. Done. Okay, next is part 4 of B, the last part of question number 18. So here the question says the diagram shows the track of the omega plus particle in the bubble chamber. Okay, we can see the track. This is the track showing the track showing the pathway of omega plus particle in the bubble chamber. So the question is asking to add to the diagram to show all tracks visible in the bubble chamber after the decay at x. So the omega plus particle, it will decay at point x. So we need to show the further pathways of the particles from point x. So you should label your diagram. Okay, we should label the diagram. Okay, this is for 4 marks, so you should be careful while drawing it. So at first consider the equation. The equation was, let me write it down here, omega plus, it is decaying into a pion plus and a neutron. So we need to show the direction for pion plus and neutron. So now consider neutron. At first consider the neutron. Neutron is a chargeless particle, and we know that in bubble chamber, basically in detectors, particle detectors, we basically don't see the tracks of uncharged particle, right? So that's why we would not see any tracks. That is, there will be no tracks for neutron. Okay, no tracks will be seen for the neutron. So only track that will be seen, it will be for the pion plus particle. So in that case, you should be, how can you draw the track? That's the main point. Okay, so this is the track for omega plus particle. So at x, we need to draw the track for pion plus particle. So since pion plus particle, it is a constituent of the omega plus particle, so definitely its momentum, that is its mass and speed, will be less than that of the omega plus particle, because the pion plus particle, it is a constituent of the omega plus particle. Besides that, neutron, it has some of the energy from the omega plus particle, so definitely the energy, the momentum of the pion plus particle, it will be less than of the omega plus. So that means in the bubble chamber, when we draw the curve, when we will draw the curve, the track of the pion plus particle, we should be aware that it has smaller energy and momentum. So that means its radius of curvature, the radius of curvature for the pion plus particle, it will be smaller than that of omega plus particle. So since it is smaller, so we have seen earlier in the previous part 3, the two particles are going like this. One goes on that way, another one goes in this way. So definitely we will follow this way, this previous figure in part 3. So it will start from here and it will have smaller curvature. Okay, it will get curved like this. So in this way, the pion plus particle will move after the decay. Okay, and on the other way, the neutron will move, but you don't need to show the neutron because neutron is invisible in the bubble chamber. So that's the diagram that we can draw for the pion plus particle. That's it. Fine.